Welcome to our podcast on Hess's Law. Now, we spent a little time already defining enthalpy, and actually we've talked about the change in enthalpy, and we even went so far as to going into molar enthalpy change. Now, what we want to do is take this a step further and use this law, which is extremely useful in thermodynamics. If you look at this, it's a little wordy. Turns out the enthalpy change for a reaction with multiple steps is equal to the sum of the enthalpy change of each individual step. Well, what does that mean? Well, remember, enthalpy is a state function, which means we don't care about all the little steps. We care about that initial and final step and the change that occurs. All right, and again, I've used the bank account analogy where you don't care how many deposits you've made, how many withdrawals. You're only worried about how much money's in your bank account. Well, with Hess's law, or with enthalpy, what's nice is we don't have to worry about that. So let's say, for example, you were given a situation where I said, here's a reaction, tell me what the change in enthalpy in the formation that PCl5 is. And this number right here wasn't given to you, this delta H. Okay, it wasn't given to you. Well, you'd be kind of stuck, right? You wouldn't be able to do it. You might be able to, I don't know, burn this stuff and use some water and see a temperature change and calculate Q like we've done in the past. But let's just say that that is not available to you. But you have some other reactions that involve these three components, and you could figure it out. So imagine this, we can make this reaction happen in two steps. Here's step one, and here's step two. And we don't, I mean, I'm showing you this value here, but let's just say we don't know it. Well, let's look at this first reaction. If we take some phosphorus and add it to some 6 moles of chlorine, we get PCl3. Now, that's not in this reaction, but that's okay. All right. Now, look at this second reaction. I've got PCl3. Oh, I had that there, and I had that there. And I've got some chloride, and I've got PCl5. Now, is there a way that we can get these two to add together to form this reaction? And that is the beauty of a state function, is that all we've got to do is manipulate these two equations right here so that it will equal out to this equation right here. And if that's the case, then we can figure out this number. So let me show you. First of all, I like to really focus on the compounds. The elements tend to take care of themselves, but let's focus on the compounds. Look at this. This is PCl3. It's not even in this reaction, right? So it's some kind of intermediate. Well, here's some PCl3 here, right? Now, if this isn't around in the final reaction, somehow this thing has got to be canceled out. Well, things on opposite sides of the arrow, they cancel each other out. So what does that mean? That means if I multiply this whole thing right here, I've got a 2. Let me change my colors here. If I multiply this whole thing by, oops, I'm going to erase, because I surely didn't want to write a 2. How about if I multiply that whole thing by 4, right? That gives me 4 of those, and now 4 of those, right? Okay, but here's the important thing. Remember that enthalpy is an extensive property. So if I multiply this reaction by 4, what do you suppose I got to do with this value right here? Well, if you said I got to multiply it by 4, you were absolutely right. So when I multiply a negative 93 kilojoules by 4, I get a negative 372 kilojoules. All right. Now, by multiplying by 4, let's see if we can't get some kind of cancellation going here. 4 PCl3 on one side, 4 PCl3 on the other side. Okay, those cancel. I've got P4 here. Plus, look at this. I've got 6 plus 4. I've got 10 Cl2s. And that yields 4 PCl5. Now, does that match the top reaction up there? It sure does. So what are some things we can do to manipulate? Well, we can go ahead and multiply something, but again, remember you've got to multiply the heat. Then another thing we can do, and we're going to do this in our next example, is we can actually flip the reaction. So let's pause for a second, and I'll go to the next slide. All right, so here's a question. Now we're going to take carbon and carbon dioxide and make some carbon monoxide, and the question is how much enthalpy change will happen in that reaction. And here we have two reactions that are going to be involved in making this final reaction. So again, what I do is I look for the compounds. Okay. Well, there's carbon monoxide on the reactant side. Okay. There, carbon monoxide is on the reactant side. So it doesn't look like I have to do anything with this reactant right here. Now here's another situation. Here's carbon dioxide, but it's on the reactant side, right? Look at it over here. It's on the product side. So really what I need to do is I need to rewrite this. I need to go 2 CO2s yields carbon plus O2. All right, now I flip this reaction. So again, what do you suppose happens to this value? Well, if you said it would change, the sign would change, you were exactly right. So I've got to change the sign to a positive 393 kilojoules. Okay, so now so I'm going to cross this one out because that's gone essentially, right? All right, and now we have this reaction. Are we done? Well, can we cancel some things out? Let's see. Okay, so I'm just going to see if this ends up equating to this reaction up here. Okay, so I've got an O2 there, O2 there, that cancels, and look, there's no O2 here. I've got a carbon here, 2 carbons over there. So what's going to happen? That carbon's going to be gone, and one of those carbons is going to be there. There's that one. That's working well. And then I've got 2 CO2s here, and oh, holy cow. We have a typo here, ladies and gentlemen. Look at this 2 that was right there. This is a typo. That should have never been there. Hopefully you can see that. 1 carbon does not equal 2 carbon dioxide. So that is a typo. My bad. All right, so we'll just put that away. But let's look at this. So I've got a CO2 on this side. Nothing on that side, so CO2. And then, what's left over here? It looks like I've got 2 carbon monoxide. All right. Now, I've got that written out correctly, just like the top. All I've got to do is add these 2 up. So when I add those 2 together, the negative 221 and the positive 393, I get a value of 172 kilojoules. Okay. Now, what kind of reaction this is? This is an endothermic reaction, right? So if we want this to happen, if we want to make carbon monoxide, you're going to have to add some energy. So there you go. That's a real simple, quick podcast on Hess's Law. We're going to practice a number of these in class. They're actually kind of enjoyable, especially the ones where you have 4 or 5 different steps and you've got to really manipulate them, divide them, multiply them, flip them in order to get them to work out. But we'll save that for class. So if you got any questions, we'll talk about it when I see you in class. See you next time.